We do have a lot of these identities represented here. The one that you're going to need to be aware of right now, the most important of them, is this one here. Cosine squared of theta plus sine squared of theta equals 1. It's one of the Pythagorean identities. This identity helps to prove a lot of other identities. Okay. Therefore, it becomes a good idea to get to know this one. Okay. And I would say memorize it. The other ones that you see represented in your textbook, you have this one here. This is just a result of, the whole idea behind all suckers take calculus. I mean, like if I look at it, like negative theta versus theta, well, you have to remember that, theta, if it's in quadrant one, that means that negative theta would be in quadrant four. Therefore, I would expect the cosine to be the same value. It's positive in both. I'd expect the sine and tangent to be negative in quadrant 4, so it's the opposite of what thetas were. So, and that works for every other quadrant as well. So, these identities are just the result of that whole idea behind all suckers take calculus. Kind of the same. This gets a little tricky because of the fact that, we're dealing with pi over 2 minus theta. But if you think about it, if you want to think about it really thoroughly, if you look at right triangles, kind of going behind the premise, like, if I have a right triangle, I have this angle here, and I have, like, say, this is my angle theta. Where this premise is coming from is that, well, if I take the cosine of that angle, it's going to be this, I'm going to have, like, we'll say A over B here. Okay. But this angle here would be my pi over 2 minus theta. Because remember, the two angles in that right triangle should total 90 degrees, and 90 degrees, of course, is pi over 2. So if I wanted to figure out what that angle was up there, I would take pi over 2 minus theta. And if I do the sine of that angle, it's the same thing as the cosine of was this angle, and vice versa. So it's kind of just a direct result of, the fact that I do have complementary angles being the acute angles in a right triangle. This identity here, these identities are kind of just around the whole idea again, around all suckers take calculus again. Depending on how much I'm adding to the angle, it's going to depend on what quadrant it puts me in. Because if I'm putting in a multiple of pi, I'm either moving 180 degrees or 360 or some. So I'm moving like half circles or full circles away from the previous angle. That's going to give me the same reference angle, but put me in a different quadrant. And so it's kind of me like dealing with like some of the ideas behind coterminal angles as well as all suckers take calculus again. So a lot of these things that you're seeing represented here, you don't need these identities to figure it out. You can use the things that we do know about all suckers take calculus, about reference angles, about angles in a right triangle being complementary to each other, and use that to come up with the same things that these things would tell you. So if you're given the following pieces of information, the cosine of pi over 8 equals that, and these are actual values. I mean, so these are exact values, and the sine of pi over 12 equals what you see there. I'm not going to read them verbatim. I want to figure out what the sine of the sine of pi over 8 is. Okay, well, I could use the first one, the Pythagorean identity. The sine squared of an angle should plus the cosine squared of the same angle should total to be 1. So if I square the cosine of pi over 8, I get this. And I'm letting 1 be 4 over 4 because I know I'm going to be doing a subtraction momentarily. I'm going to subtract both sides by 2 plus the square root of 2. Now I have to keep in mind that even though I'm not seeing it here, there are parentheses understood to be up here. So if I have that minus sign attached to it, that's going to have to be distributed. A lot of students overlook things like that. So if I carry through that subtraction, I do get that the sine squared of pi over 8 equals 2 minus the square root of 2 all over 4. And if I do the square root of that, now, a couple things about this, yes, generally when I do a square root and put it into a problem where in the previous steps one wasn't there, So I'm putting a new one into this. That plus or minus symbol should really be there. However, pi over 8 is in the first quadrant. Think about it. I mean, if you need to figure that out, 180 divided by 8, you're talking about 22.5 degrees. You're in quadrant 1. And in quadrant 1, the sign is going to be positive. So these are trig functions. Therefore, the plus or minus symbol wouldn't make sense there, because I'm saying, well, if I put an angle in, I'm going to get two different values for it. Well, that's not a function. So that's how I know it's going to be positive here. The cosine of 7 pi over 8. 7 pi over 8 and pi over 8 are supplementary. 7 pi over 8 shares the same reference angle as pi over 8 does. Okay? Therefore, numerically, I'm still going to see the square root of 2 plus square root 2 all over 2 as part of my answer. The thing is, the only thing that's going to be different is in pi over 8 in quadrant 1, cosines are positive. In quadrant 2, where 7 pi over 8 would be, they're negative. So the only thing that's going to be different here, I'm just going to put a negative sign in front of the value for cosine that I had up here. So it's just comparing these two. It's going to be a sign change. As far as the next one goes, I think I actually have the slides giving me more room to do this. Pi over 12 is the reference angle for this. I mean, here's pi over 12. I know what the sine of pi over 12 is. 23 pi over 12, and here's like the side measurements I would be able to do with this. Okay. So I have the square root of 2 minus square root of 3. I have the x value, I have 2. I can figure out what the x value is going to be. It's going to be 2 plus square root of 3 all square rooted. Now the reason why I'm doing all this for pi over 12, because I'm using the sine of pi over 12 to help me with this. The tangent of pi over 12 is going to be that value. 23 pi over 12 and pi over 12 have the same reference angle, pi over 12. So I know that the tangent of 23 pi over 12 is going to have the same number as I see down here. The only thing that's going to be is it going to be positive or negative? Well, 23 pi over 12, as you can see, puts me in quadrant 4. And in quadrant 4, tangents are negative. So if I make the tangent negative, that's the final answer. So that's me using those identities, the thoughts behind them. But as I said, the thoughts behind them are all suckers take calculus, coterminal, reference angles, all those concepts we talked about throughout this entire chapter 4 discussion. So as I said, those other three boxes that we had following the Pythagorean identity, which was the very first box that you saw as far as identities go, were all ideas centralized around coterminal angles, reference angles, all suckers take calculus, and the concepts behind them. So you don't have to have them stated as such to do the problems and figure them out. Okay.